Hi, how's it going? Okay, so very much aware that this is right after lunch. So this is when people are going to either be inclined to have a nap, or maybe you missed lunch and now you're going to be grumpy because you haven't had it. We'll do what we can to be interesting, maybe a little entertaining. The idea here is to tell a story, to explain what we have gone through in this effort. We're going to do our best, and we're happy to be here. So right off the bat, hi, I'm Rex. I am a strategy senior. Oh, I was trying to figure out what was weird going at the bottom. They have captions. Okay. I'm strategy senior principal at Accenture. I'm also the lead data and cloud architect for the West. Most of what I do is whenever we have some kind of work for public sector, I'll go in, I'll see what work needs to be done, we'll come up with a design. And we've been doing some very, I would say, impactful stuff in the last couple of years. This is my partner in crime, Mike.
And I'm Mike Pozorski, a solution architect with Mosaic Data Solutions. And I am the consulting architect for the customer in question for this project.
Here we go.
All right. So kicking off, we're going to start off with a little bit of background about what a IIS is in our world in this particular customer project. Talk about the decision to move to Databricks. Rex is going to go a lot into the insights gained from that process and go over the solution at the end. So in the beginning, there was the IIS, and it was good. But what is that? What is the IIS? So an immunization registry is exactly what that sounds like, right? It's a collection of all the data that's about any immunization given in the public sector space. So in our case, it's a very large public sector. We have millions of patients that are getting immunizations every year, and the IIS is there to track those patients, the immunizations they receive, as well as to answer questions to doctors, such as when should they get their next immunization? What are they missing? What do they need to receive during this visit or maybe a future visit so that they can be as healthy as possible, right? That's the idea behind public health in general. There are a lot of elements that go into designing an IIS, and some of them are listed here, but the main one is to securely and confidentially hold that data, because this is public records about all of us, right? These are our fundamental elements of us. It has all of our PII in it, has all of those details. So the history of IIS is fairly long, actually. It's been a concept for the last about 30 years. However, in the beginning, it was really implemented at a much smaller scale. So generally, counties or local health jurisdictions, we call them, would have their own IIS where they received immunizations from their partners, which are the actual hospitals and facilitators of immunizations. Over the years, that has been rolled up and up into larger communities, and at this point, pretty much every state has a central IIS that is the repository for all of that data. And the real reason for that is that people move around, right? They move from community to community, and we want to be able to track those immunizations between them. This brings us to the real need for a immunization analytics platform, where we can look at, during COVID, it became really, really apparent that we didn't have access to all the data that we needed to successfully get immunizations out to communities and to target communities that were at the highest risks. So we needed a way to open this up to a larger scale platform, rather than just doctors, but also to virologists and to immunologists and to the local jurisdictions that needed to see who in my county hasn't received an immunization. What are the underserved communities in my community? So it's gone through several iterations. We started off with a very, very rudimentary version of it, where we just kind of threw it up into a cloud provider that had SQL access, and we gave that out to all of our local health jurisdictions. That was a very quick and easy way to get it out there, but it wasn't very efficient, it wasn't very secure, we started layering security on top of that. So it's gone through several revisions of that over the years since COVID to make it as secure as possible and as efficient as possible. So that brings us to the last iteration. And I'll bring up Rex to continue on that.
This next one, I think you...
Oh, right. Talking about the decision why. So one of our big drivers for Databricks itself as a platform was a better integration with our cloud architecture. This customer has a substantial investment in Azure as Microsoft as a whole, but specifically Azure as a cloud partner. So being able to integrate directly into that ecosystem and use all of the security capabilities that we'd already built on that platform for our other services was really essential. And a lot of the other providers of this type of architecture don't do that, right? They have a black box architecture where you use theirs and you do what you can to secure it. We wanted to bring it into ours because we have, Sentinel and all the other Azure tools at our disposal within the Databricks because it's in our Azure tenant. Major thing we wanted was the monitoring of capability. Again, it being in a black box architecture, we don't have a lot of visibility into that to see what's going on with the data, with who's accessing it when there's an outage. Came as a bit of a surprise at times, unfortunately. So, and then being able to tune it was essential because it's a very large data set. So being able to tune that for fast access and fast queries across many, many customers of that data was essential. And getting data into it. One of the major struggles we had is that, of course, this didn't replace our existing immunization registry. The analytics platform had to be able to quickly get a lot of data into it and be able to do that at not only quickly, but on a timely manner. So every hour we wanted refreshed data because that's the level of decision making we were making in the middle of COVID. So we wanted to be able to get a very large amount of data into it really on time. And I think Rex will touch a little bit on what those somewhat unreasonable timer demands were. And then the ability to integrate with other systems. So again, having this ecosystem for the data really opens up what our partners can use, can bring to the table for their data analytics. So we're an entity that has a lot of data, and we use it constantly internally, but we had so many demands from external partners, whether it be our jurisdictions or the CDC, that need to get our data so that they can do their analytics. So being able to integrate with these multitudes of systems was really, really important. And then continuous innovations was really key. We were seeing a little bit of a stagnation in capabilities with our other platform that was really holding back some of the innovations that we wanted to do because we didn't have the underlying innovations of the platform. And the last one gets covered up completely by the subtitles, unfortunately.
Machine learning and AI capabilities.
Oh, right. So machine learning and AI. So that, talking about the efficiencies, one of the other things is that a lot of our data computations were really, we had no AI or ML to be able to bring to bear to it. So we had these very lengthy processes that were going into the data and mining and extracting, up-level data, but they weren't very efficient because we couldn't use some of those AI and ML tools that are available on the market. So that was another key element to Databricks.
Okay. All right. So let's kind of make sense of what this whole IIS thing is and what we're trying to do. Okay. How many of you remember something that went down in 2020 that might have interrupted your lives? Okay. Something may have happened, right? Something went down. This big effort was mostly a result of that, okay? We want to be able to keep track of who got sick, of who is getting better, of who is protected. The whole point is to keep everybody safe. That's the point. We want to be able to say, bring up a map, look at a community and say that community might be in danger. What can we do? Well, we can put in an advertising campaign over there. Or we can do something to motivate them. We can make sure there's healthcare in that area. This is the whole point of the IIS, okay? The immunization system. That's the point. It's to keep you healthy, to find out where there's a risk. This went beyond COVID. Now this includes all vaccines. But it also means we're going to be able to do stuff like, hey, no one got their flu shot this year. Are we screwed if someone gets the flu? We get answers to those questions. Now, it's important that we have answers to those questions. So we wanted to move from this old cloud data warehouse, which shall remain nameless, who had a summit last week, over to Databricks. We, as Mike said, we had some good reasons for this. Now, the reality is, whenever you do a big move like this, there are certain business expectations. I don't suppose any of you received some business expectations that might have made you go a little stressed, crazy. So, of course, they wanted everything to work exactly the same way it did, but it has to do more. So, right off the bat, we say, okay, we're moving to a new system. It has to be the same time, okay? So we said 45 minutes is the time. Okay, native Californians, okay? The rest of you, I assume, are out of state. Anyone out of country? Okay, we got a few, cool. Now, a lot of you probably had some kind of app, some kind of tool that lets you go ahead and say, I've been vaccinated, okay? Some of you, you go to an activity, they like, show me proof you got vaccinated, you've got your app. Well, the whole reason we had to do this in 45 minutes was so that you could go in and show your phone and say, I got vaccinated. And if we did our job right, you could go get vaccinated and that evening go into some kind of social activity and shine your phone. That was the goal. 45 minutes was the target. 45 minutes to load all the data from that main IIS database into our analytics platform, and then from there into whatever it was that's going to let you shine your phone or whatever you need it to be, okay? 45 minutes. Second thing is, it's got to cost the same amount. Okay, your boss comes to you and says, hey, I want you to add all of these new features. It has to go the same speed and it has to cost the same amount of money, okay? That was our situation, because that's always a search situation. Next is this master person index thing, okay? Master person index. Many government organizations have rules about the kind of identifying information you can have. For example, we were not allowed to use social security numbers, okay? How do you then dedupe people? How do you find out whether this person who got a vaccination today, or let's say 2 months ago, it's the same person who's getting their second shot? How do you do that? Well, we had a bunch of simple formulas we could do. We had a very simple query. We called it the 3+1. You know, we're going to match their first name, their last name, their address, their phone number, and then something else. Yeah, that was the +1. Well, you get people to move, people to change phone numbers. We got a way to track that. So we built this whole master person index. In fact, that was the main driver for me to do this. The master person index that we built is an AI tool, it's an ML tool, that is basically a giant classification system for 52 million people to determine who is the same person, okay? This is a thing that they wanted to take the same amount of time and cost the same amount of money, okay? That's what we had to fit in there, okay? The other problem was the code. I'm going to show you a slide in a second of what the code looked like, okay? Or what the workflow looked like. The code was a mess. We needed some kind of way of keeping that organized and easy to follow. Historical data, okay? We all know about time travel. Time travel, pretty neat. But if you want to be able to track one person's record throughout time, time travel ain't going to do it. That was one of our requirements. We had to be able to do that, okay? And then data governance. We're a state. Sure, we threw this all together in the last minute when COVID happened, but now we had to actually govern our data. We needed to know where it was coming from and that information, okay? And then you can't really see it at the bottom. It had to do CI/CD, and we had to do at least unit testing, but all had to be automated. This, which is hard to see, but frankly, it was hard to see in real life, is kind of what our pipeline looked like in the old system. The whole thing here was, it was kind of emergency. Someone come in and say, we need blank feature right now. Well, that didn't really give the team a lot of time to go and put into a good structure. So instead, it all got slammed in, and gradually it became crazier and crazier and more intense. And we needed something to force the developers into a framework, to make it so it didn't matter if you had to be quick. You still had, the code still had to make sense. The pipeline had to make sense. It had to be something we could organize it. And I don't know if this has happened to you. One guy, just one guy, knew how everything worked. If that one guy got hit by a bus, we were screwed, okay? Some of you are that one guy, and shame on you. Okay, so what we looked for is, first, we were using Azure Data Factory for our orchestration, okay? We had a couple reasons for this. One is we're working with a lot more systems than just Databricks. It would be nice if we could all do it in job workflow. No, because we had to work with event queues. We had to still use that other data warehouse. We still had to interact with these other systems. So we use Data Factory. Also, it's an Oracle database. It's on-prem. It takes some finagling to get that data out. We're going to use change data capture. No more are we going to do everything as a trunk and load. We had 52 million people and 650 million immunization records that we were pulling in as a truncate and load every freaking hour. That had to go away, okay? And then the Delta Live tables. This was our solution to force everyone to get into a framework when they coded it. We had a lot of other reasons, resource management. I just like them. I like saying DLT a lot. It sounds like a BLT. So we were going to go to DLT. And then something that we're going to talk about is SCD Type 2, okay? We were going to use that to track the history, okay? Built in, it works. We do the whole, unchange command for loading in DLT. It just does it. Cool. And then Iceberg compatibility was also something. And I'm not going to talk about it again. Just thought I had to put Iceberg in there somewhere. Okay. Here are the things we learned. 1, know your data. 2, understand the structure you're putting data in. That I'm just going to talk about SCD Type 1 and Type 2. Understand your cluster strategy. That is more of a change management conversation. And decouple workflows, that's how I cheated to make everything work in time. Okay, assumptions that we had here, okay? We assumed that change data capture was going to work in Oracle. We weren't using Golden Gate. We had to kind of hack it. It worked. Cool. We needed to be able to put everything in a blob container. Sure, it's fine. Autoloader picked up the data, doing okay. And then we said, okay, we've got the system that is doing new immunizations with a few updates, okay? So what's a logical assumption you have here? I'm going to get primarily inserts, and I'll get a couple modifications. Well, that's where things went to hell, because it wasn't true. Here's our reality. We went to do our updates, and they took a ton of time. It took 30 minutes, okay? 30 minutes, and I still had to do all this other work on the back end. We weren't able to do it. Our logs indicated that almost all the partitions were being updated. Not just the one big new one and the couple in between, all of them. Out of 90 partitions, 82 were actually getting updated, okay? CDC, that was fine, but here's what happened. Another group handles the IIS, and the way the IIS was designed is that anytime there was some kind of change to a shot, change to an immunization, it would go and update every single record in the database, okay? And this happened a lot. It happened so often that, Well, it was 30 minutes every freaking time. We'd run it 15 minutes. It'd still take every 30 minutes. That doesn't work. The math doesn't add up. These are our problems that we ran into. And we tried a lot of stuff. We said, okay, let's partition by the date it was put into the system. Let's partition by the date the shot was actually given. Let's just do it by ID number. Let's do it by the recipient. Every single time, every single partition had to get updated. That was our reality. So what did we have to do with this? Or what was the impact of this? Okay, we knew it was going to be 90%. Gut response. How many times do you go in and say something is wrong in Databricks? What's the first thing people say? More workers. Okay? Add more workers, increase your cluster size. That is the first answer that always comes up. Well, remember what my requirement was? Like rule number 2 was it can't cost more. I can't just throw workers at it. That wasn't going to happen. Okay? So lesson 2, we're going to talk about that whole SCD Type 1, Type 2 thing. And we needed to just do more change data capture. We upped it to every 15 minutes. It worked out okay. So, thought we were going to have it nice and easy, new partition, a few updates. Didn't happen. 90% had to be updated. And we had to change some of our original design. So, data structure. That's what I'm just calling SCD Type 1, Type 2. We liked Type 2. We liked it because, like I said, we had that history thing we wanted to do, okay? There's a lot that goes into Type 2, and we'll talk about it in a slide or two, okay? We assumed that it's going to get bigger. Like every time you do a Type 2, you're adding a row for every single change. It grows. But again, we assumed one big insert, a couple little ones. It's okay. Maybe it's going to be twice as big, maybe 3 times as big eventually. That's doable. We can do that. What we couldn't do is 50 times as big, which is what we got. So, quick recap. Slow changing data, SCD Type 1 and Type 2. Let's say that's your input. I'm going to get a user ID. I'm going to get a name. By the way, I totally ripped this off the actual documentation. I'm going to get a city, insert a sequence number. Okay? Type 1. I just start from scratch. I go, what's the latest number for each of these guys? Okay, that's it. Boom, there's your Type 1. It's simple, it's straightforward. What I read is what the real current data is. Type 2, I'm going to get a start date, I'm going to get an end date, and I'm able to kind of see the history as I go through that. Well, every time you make a change, you're writing a new partition, right? But there's more in a Type 2. In a Type 2, you're not just writing a new partition, you're going through and looking for every single row of what you had to change before, okay? There is a massive join that you've got to do so that you can update that end at slot, okay? So now, again, 650 million shots, 52 million people, and it's growing. And then we talked about the fact that our data coming in, there's a change in every single partition. What that really looks like is over the course of, say, a week, we have a whole new set of data. This thing wasn't growing to be 100, 200% bigger. It was growing to be 1,000, 2,000% bigger. It was growing huge. And every time you did this, it had to do that join again in order to update that data. No bueno. It's not happening, okay? So let's go to the next slide. We still had to track it. It was clear that wasn't going to work. So we said, okay, we're not doing it. Type 2 is going to work in general. What we ended up doing is we still did Type 2, but we did it once a day, maybe less. And we said, okay, guys, you're just going to have to deal with the fact you're not going to get a 15-minute interval of history. You can have it in a day and be happy with that. And frankly, if I can get away with it, I might do less than that. No one's actually asked for the data. Maybe they won't miss it. How often does that answer work? Yeah. Okay, so understand data structure. That's how it went down, okay? We assumed we can use Type 2. We couldn't use Type 2 because of lesson number 1. And and the impact was we just had to drop that. Okay. Cluster strategy. By the way, do you know what's frustrating about doing these before the keynote? It's that we're going to have this keynote and they're going to come back and they're going to tell me that they've solved half of these problems, right? We're going to come back and they're going to say, oh, yeah, don't worry about that, don't worry about that. Cluster strategy, okay? So this is more of an organizational thing. This is how it grew. When Databricks was introduced, it was introduced as more of an analytical service that was going to be used. This was not thought of as a big ETL, ELT operation. It wasn't thought of doing lots of pipelines. It was thought, I'm going to grab my data. I'm going to take this dude from epidemiology, and he's going to sit down in front of here, and he's going to run some Python or some R, and he's going to be happy. Okay? That was kind of the assumption. So that means you're not going to have a big team. You're not going to really have planned out your instances in such a way that you can go nuts with them, that you can scale them all the way up, scale them all the way down. You're going to assume, hey, this guy only needs this type of machine. At most, 5 workers, that might be a little much. Those were kind of the assumptions that were going into this. And it was just, that was how things were working. And this wasn't, no one really dropped the ball. This just was the experience that was going on. So we had to kind of work with the organization. We had to kind of have these discussions of how we were actually going to redo some of that, okay? So we got different clusters types, right? We've got our integrated, we've got our DLT, we've got our job clusters, okay? And one of the things that we're taught is if you're doing production, for heaven's sakes, do not do production on an integrated cluster that lots of different people don't share. Well, that's what we did because that was how things were built. It was built, you have integrated clusters. You are going to use these, okay? And we would run into these problems where should work once the first time and then it would die. So what do we have to do then? We've got to restart them. It was just a mess, okay? So now we had to introduce some new ways of doing things. We had a great team, okay? The people we worked with at the state side were wonderful. We had good conversations. We gradually started to introduce things. We gradually started loosening things up. We worked with our Databricks team. They were instrumental in having this happen because we can have those conversations. We can then all get on a call and go, yes, this is the right way to do it. This is how we're going to make it work. By the way, I kept saying integrated. I meant interactive. You knew that, right? So, impact. We needed to work with the organization. We needed to come up with new strategies. We needed everyone to be comfortable with using different types of workers, different sizes of workers. Their idea of what large constituted was modified quite a bit. And we gradually moved everything away from the interactive and over to just job clusters and DLT as we implemented that. Okay, last on the list, decoupling the workflows. Okay, this is where we read the fine print and cheated. We have 45 minutes to get everything done. We have set up our DLT so that we can bring in our bronze and our silver every 15 minutes. So far, so good. Well, we did this thing. We introduced a master person index. We had an MPI we put in. Remember, that is a big 52 million categorization exercise. It is not a little thing. That's got to fit into that. So we've got to be able to pull in all the updates for the 52 million people, and then we've got to compare them against themselves, find out who's actually the same person, update the record, we call it bridging, so that we really knew who was the same person. That takes time. No matter how you do it, it's going to take some time to do. So we had to build that in, right? We had assumed we assumed the thing I talked about earlier. just up the cluster size. That didn't quite work. Also, the whole reason we assumed we could do it in 45 minutes is that's what we did in the old system. And when we did in the old system, we knew that the 45 minutes was 45 minutes to get it into the system and 45 minutes to have it stable for other things to access it. And we just assumed they were actually the same exercise. So we had the one following the other. It made sense. Fine. Well, we kind of assumed that was the original requirement. It wasn't. So we cheated. We decided what we needed to do was to treat them as two entirely separate problems. Okay? Here's how it worked. Our particular statement that we made was that in 45 minutes, the data would be available in the data warehouse, in the data lake. Well, data lake house, because we like buzzwords. That was a requirement. And heck, we're doing that every 15 minutes. We're good. The second requirement was that it be stable so that it can move into other systems. They don't have to be the same thing. So, every 15 minutes, we do silver and bronze and silver. Once every 45 minutes, we do gold. But let's say our bronze and silver aren't ready on time and we start the process with a master person index. It's okay, because worst case scenario, it's going to be off by 15 minutes. That's fine. 15 minutes is fine. We've kept our obligation to keep it in the system, to make the data available from when it goes into the registry to when we actually can get access to it. That's good. Our system is totally stable and ready to go to push out to other people. 45 minutes, that's good. Change data capture is working just fine. Everything worked out. So far, so good. Okay, and last, let me show you. There's a summary. What it looks like in the end. This is very simple, very straightforward. You've all seen something like this before. We have our IIS. We have Azure Data Factory, which is pulling the data in, doing our orchestration, drops in Azure Data Lake. Then we have the Delta Live tables. Delta Live tables are going to continuously pull it in. They're running all the time. Data comes in, picks it up, moves it in, boom, bronze, okay? We do our transformations. We clean up the data. This is your typical medallion architecture. We pull in the data. Boom, we got our silver layer. Then it's on a schedule, okay? The schedule, once an hour, it kicks on, and we're going to do the MPI work, okay? So the master person index takes that whole list, scans it, finds any of the duplicates. We're going to join people together. I keep saying 52 million people. Well, a lot of those are actually duplicates. So we find those people, we get them out, we stick to who are real people, and finally ends up with our gold. What happens from there is it gets pulled into the application like we were talking about earlier. It goes to the other CDC, the Center for Disease Control. They get readouts of what's going on. It goes to the counties, the LHJs, so local health jurisdictions. They all have their own teams who are pulling the data. A lot of it, I mentioned we did the iceberg thing. We drop in iceberg tables. They go into Snowflake. Sorry, I'm not supposed to say Snowflake. They go into the other people. And that's what some of the LHJs are comfortable with. That's where they get their data. Works fine. And then, like I mentioned before, we have since moved everything over to a job workflow. It's finally working. It works great. We're at a happy place. In fact, when this thing first started to blow up, it was almost exactly a year ago. I was pulled out of one of these sessions in order to deal with my team saying, OMG, this is never going to work. What are we going to do? And I'm happy that we have come a long ways and we finally get here. All right, that's it. Thank you. Now,